Hi friends, in this video we are going to see how to apply KVL to a simple circuit. So let's take a circuit. And in this circuit I am considering these 2 points A and B. Let's give value to all the elements. So it's a 10 ohm, this is 5, 30 volt, 15 ohm, this is also 5 volt, 4 ohm, 6, again 4, 10, and this is 20 volt. And we are supposed to find out what is the potential difference between points A and B. So VAB we are supposed to find out. So before applying any law, let's give name to all the nodes present. So I will consider this as a point C, point D, E, F, G, and this point is H. Now to get a VAB, I can trace from point A to point B in any of the path without completing a loop. I repeat, to get a VAB, I need to start from point A and end on point B without completing any loop. So I can have the path like this: A, C, D, E, F, G, B, or I can have a path A, E, F, H, B, or else I can go like this: A, E, F, G, B. But I cannot take a path like this. For example, A, C, D, E, and then again A, because loop is getting completed. I need to cover these 2 points, but whenever I am covering these 2 points, there should not be any loop which is there in a path. So I will consider a simplest path from A to B like this: A, E, F, H, and B. So the first thing is that I need to select the simplest path. So I have selected the path. Now in a path, number of elements are appearing. I need to mark the polarities of potential differences between them. Meaning, here I am having 15 ohm, 4 ohm and 10 ohm. So I need to find out what is the voltage between them along with the polarity. At the same time, I need to know what is the potential differences of this, which is already given. The polarity will be like this: plus minus, this is plus minus. Now for the resistances, I need to find out current flowing through it. So I will consider this loop to get a current, because here I am having a one potential source and remaining resistances connected in series. So I'll consider the current will flow like this, and I will mark it as, say, I1. So I1 I can get by Ohm's law. Its voltage is 30 divided by total resistance connected in a circuit. So it's a 5 plus 10 plus 15. The answer I will get is 1 ampere. Similarly, I need to know what is the potential for this 10 ohm. For that purpose, I should know the current flowing through the 10 ohm, which is supplied by this battery. So I'll mark the current like this, I2. Again in this loop, I will have only one potential source of 20 volt divided by total resistance in a circuit, which is 6 plus 4 plus 10. Coincidentally, here also I will get the same answer, 1 ampere. Now I will redraw the path which is required to calculate VAB, meaning I consider this path, so I'll redraw over here. this is point B, this is point A. Here it is 15 ohm, 5 volt, 4 ohm, 20 volt, and this is 10 ohm. Now I will mark the polarities of voltage that is across 15 ohm because of this I1. See the current direction, it will be like this. So the polarity will be plus to minus. One thing you have to remember, whenever a resistor is connected to a potential source and current is flowing, voltage drop is always developed in a direction of current. Meaning if I1 is flowing like this, potential drop will be plus minus in the direction of current. Same way for here, I am considering I2 like this. So for this 10 ohm, it is like this. So the polarity is plus minus. So here for 15 ohm, polarity is like this. And the current flowing through the 15 ohm is I1. Already we have mentioned the polarity of 5 volt, no need to mention. I will come to the point for this 4 ohm later on. First, let's mark the polarities of remaining elements. For 10 ohm, the current will be I2 downward and hence polarity is plus minus. 4 ohm, it's not a part of any closed loop circuit. See here, if it is closed through some element, then definitely this 5 volt is going to give rise to some current to this 4 ohm. But there is open loop or open circuit between points D and G. Therefore, I should not have any current flowing through the 4 ohm. So current flowing through the 4 ohm is 0. So I'll mention over here, current flowing through the 4 ohm is 0 because it is not a part of any closed loop circuit having a battery. Now I will apply KVL to this particular path, or I will consider a loop. So see how I am going to apply the KVL to this particular circuit. So I will apply KVL to this circuit now from A to B. So I am starting with the point A and I will consider a potential of point A as VA. And now in the direction which is starting from A to B, I will have potential difference for this 15 ohm as a voltage drop, because in this direction it is plus minus, which I will consider as drop. Same way here, plus minus, and only for 10 ohm it is voltage rise, because in this direction it is minus plus. So I will write a equation. So starting with A, so VA minus I1 into 15 minus 5. Since there won't be any current flowing to the 4 ohm, so potential drop is 0, minus 20 plus I2 into 10, and finally I am ending my loop at B point. So I will consider B at lower potential, so minus VB equals 0. So I can club VA minus VB, and then I will substitute all the values. So I1 and I2 both are of 1 ampere, so 1 into 15 minus 5 minus 20 plus 1 into 10 equals 0. VA minus VB ultimately will become VAB, potential difference between points A and B. So after solving this, I will get 15 plus 5 plus 20 minus 10. So after solving this, I will get VAB as 30 volt, and since I am getting a positive answer, that means here I have assumed A is at higher potential compared to B, which is correct. So I will write here A positive with respect to B. So here I mentioned the potential difference value along with the polarity. So here we have seen how we can apply a KVL to a problem and get an answer for a circuit. Thank you.